Hey guys, what's up? It's Chapter 8, Systems of Particles and Linear Momentum. Introduction. When Newton first expressed his second law, he didn't write F equals ma. Instead, he expressed it in the law. The alteration of motion is proportional. The force impressed. By the motion, he meant the product of the mass and velocity, a vector quantity known as linear momentum. So in Newton's original formula reads this. The change in momentum is proportional to force. But a large force acts for a short period of time can produce the same change in linear momentum as a small force acting in a greater period of time. This is thus known as this. His equation thus can become F equals ma, since change of p over change of t is mass times velocity. Velocity over time is ma, assuming that m remains constant, which we assume will. A golfer strikes a golf ball mass of 0.05 kilograms. The ball of impact is 1 microsecond. If the ball acquires a velocity of 70 meters per second, calculate the average force exerted on the ball. Okay, so we can start with our picture over here. This is the golf ball, this is the club, and we have 1 millisecond. So that's 10 to the negative 3 seconds. I think I'll also be on your AP sheet if you want. And since we know the mass is equal to 0.05, we can use this information to find the momentum or the force applied, which is equal to change of momentum over the change of time. And since we know momentum is equal to mass over velocity over change of time, we can use this information, just plug in what we have, really, and then using that we can get 790 pounds or 3,500 newtons. Impulse. So the product of a force, the time which it acts, is known as impulse. I don't know where that went, but let's reopen it. Okay, when we think about it, velocity, mass times the change of x, that's what impulse is. Mass times the change in velocity, because force is mass times a. Mass times a. Since we're multiplying by time, it's going to be mass times the average of velocity, and thus that would be the change of p. Does that make sense? So impulse momentum theorem is also referred to another way of writing Newton's second law. If F varies with time over the interval which it acts, then the impulse is F in terms of Ft from time 1 to time 2. And in the equation sheet, it's given like this, which makes sense. If the graph of force versus time area is given, then impulse of force, F, acts from T1 to T2 equal to the area bounded by the graph of F. The t-axis and the vertical lines associated with T1 and T2 are shown in the following graph. football team's kicker punts the ball mass 4.4 kg and gives it a launch speed of 30 meters per second. Find the impulse delivered to the football by the kicker's foot and the average force exerted by the kicker on the ball. So, we know that the mass is 0.4 and the launch speed is this. So we know this is equal to this. Mass times velocity. We also know impulse is equal to the change of mass. So we're looking for the average force. So using this information, since we know the momentum, we can find the momentum 0 to 8, which is the same as just finding the momentum. That's 8 since the velocity, and this does not change. Thus, we can write this in terms of 12 newtons. Right, hopefully. I'm just gonna grams per meters per second, I think it's second squared for newtons. Yeah. So, average force. So, average force is simply just divided by time again, which if we divide by 8 milliseconds will be way more, right? Because it's 0.08 or 8 to the negative, what is this? 10 to the negative 3 times 8, the denominator. So that times 12, positive 3, 96, 9.6 times 10 to the fourth. It's the same as this. I don't feel like doing this right now, so I'm gonna clear my head now. See you guys later. Peace, love you.